Alright guys, we are going to do property of exponents. So first let's explore some patterns and go from there. Here, 2 to the 4th power means we have 2 multiplied to itself 4 times. 2 cubed is multiplied to itself 3 times. 2 squared is multiplied to itself twice. And 2 to the power of 1 is just a 2 by itself. So exponents tell me how many times to multiply it. 2 to the 4th will give me 16. 2 cubed is 8, 2 to the power of 2 is 4, and 2 to the power of 1 is going to be 2. So what do we notice? Well, I notice that as my exponent decreases, it looks like our value is also decreasing, but it's decreasing a certain way. 16 to 8, 8 to 4, 4 to 2, looks like I'm dividing by 2 each time. And if I look at my original expressions, 2 is my base. So as my exponent is decreasing, the value is being divided by the base. Which for all of these problems, our base is 2. Okay, so as my exponents go down, our values are also going down. They're being divided by the base of 2. So let's continue. So my next on my list, I had 2 to the 1st power, right? We had 2 to the 1st power, which we knew was 2. I go down again to 2 to the 0. Well, I take my other value, 2. I divide it by my base, which is also 2. We get 1. This is our first property. Any base I ever have, if it's raised to the power of 0, it will always be equal to 1. Every time. It could be 10 to the power of 0. It could be square root of 2 to the power of 0. It could be negative a million to the power of 0. They all equal 1. Okay? Next property. So if I keep decreasing, so I had 2 to the 0. Now if I go down to 2 to the negative 1, well, I'm still going to keep dividing by 2. So 1 divided by 2 is our next value. That's the same thing as saying 2 to the power of 1, right? If I go down again, I'm going to divide again. Now we have 1/4, which is the same thing as 1 over 2 squared. Okay? So notice what happened. 2 to the negative 1 became 1 over 2 to the 1. 2 to the negative 2 became 1 over 2 squared. So what's happening is we are essentially flipping what part of the fraction that this is on. So if I have a negative exponent, it is going on in my numerator, it will get brought down to the denominator, and my exponent is now positive. If your negative exponent is already in your denominator, it means it's in the wrong spot. So now it needs to get flipped up into the numerator. So a negative exponent is expressing that something is in the wrong part of a fraction. Okay? Like I'll show you. If I had like x3 over y to the negative 5, this negative 5 shows me that the y is in the wrong spot. So x cubed will stay where it is, but y5 needs to get brought up to the top because of that negative exponent. So that's what I mean. It needs to get shifted around. All right, our next property is the product property. So there's going to be something I can do if I'm multiplying same bases with different exponents. So let's explore. 2 cubed means I have 2 times itself 3 times. 2 to the 4th means I have 2 times itself 4 times. So in total, I have 7 2's here. So that's 2 to the 7th. So how did 3 and 4 become 7? Okay, let's see if I do this again. 2 to the 5th means I have 5 2's. 2 to the negative 3 means I have 3 2's, but they should be in the bottom because of that negative exponent told me it was in the wrong spot. So my 3 2's go to the bottom. Here, I start canceling out common numerators and denominators. And we are left with 2 2's in my numerator, so 2 squared. how could 5 and negative 3 turn into 2? Last example, x cubed means we have 3 x's. X squared means we have 2 x's. And in total, we have 5, so it becomes x to the 5th. So what happened? What did we get to do with our exponents each time to get the simplified blue version? We got to add them together. So that would be the same if I added 3 and 4. This is the same if I do 5 plus negative 3. That does equal positive 2. Here, this is 3 plus 2. So instead of doing the red and the green, I can use my property to go from my beginning expression to our blue simplified expression by adding our exponents together. All right. When we're dividing pieces that have the same base but different exponents, let's see what happens here. So 4 to the power of 5, I'm going to expand this out. That means I have 5 4s. And then my denominator already has 4 cubed. It is not a negative exponent, so they're going to stay in the denominator. All right, cancel out common pieces. We're left with 4 squared. Okay, so 5 and 3 became 2 somehow. Let's do the next one. X to the 7th means we have 7 x's in my numerator. And x to the 8th with a positive exponent, so it's in the right spot, means we have 8 x's in my denominator. All right, I'm going to start canceling out common pieces. Looks like I canceled everything out of my numerator, so I have a 1 left over. Got to put something there. My denominator, though, still has an x left over. All right, so I could rewrite this as x to the negative 1, right? Those are the same thing. That's going to help you see the pattern. So 5 and 3 became 2 somehow. 7 and 8 became negative 1 somehow, and then it got flipped to the right part of the fraction. What did we do? We subtracted our exponents. We did 5 minus 3 to get the 2. It's always numerator minus denominator. So here, this was 7 minus 8 to get negative 1. And then we used my negative property to put the x in the right spot, which is now the denominator. All right. Our next one. Looks like we only have one base this time, but I have 2 exponents. So I have a power to a power happening here. All right, well, 5 cubed raised to the power of 2, that means I have 2 5 cubes. A power of 2 means it's being multiplied to itself twice. Okay, so I have 5 written out 3 times, and I have it twice. So how many do I have? I have 6 total. Okay, so how did 3 and 2 get written as a 6? Think about it. Our next one, we have y to the 4th cubed. So that means we have y to the 4th, we have it 3 times. So if I write all that out, so this one, 1, 2, 3, 4. All right, and then this piece, 1, 2, 3, 4. And then my last piece, 1, 2, 3, 4. How many total y's do we have? We have 12. So we have y to the 12th. So how did 4 and 3 become 12? Our property here is we get to multiply. This came from saying 3 times 2. This came from y to the 4th times 3. So power to a power, we get to multiply them together. All right, we have 2 more. All right, our last 2, we have a power of a product and we have power of a quotient. Okay, so here I have two values inside of a parenthesis being raised to one exponent, and the two values inside are different. Okay, so 2 times 3 squared, I can write that twice, which means I have 2 2's together. I also have 3 3's together, so I could simplify that to be 2 squared and 3 squared. So I had 2 and 3 on the inside with an exponent of 2 on the outside, and I got 2 squared, 3 squared out of it. So think of what pattern we might see. This next one, we have 4x cubed. So we're going to have 4x, right, written 3 times, which means I have 3 4's. We also have 3 x's. So that's 4 cubed x cubed. So 4 and x on the inside, cube on the outside, becomes 4 cubed x cubed. So what's happening? Each piece inside of our parentheses is getting the exponent. So when I have pieces being multiplied inside, we're going to distribute the exponent to each piece. So we got to give the exponent of 3 to the 4 and to the x. Here I got to give the exponent of 2 to the 2 and the 3. All right, our last property is the power of a quotient. So here, 20 divided by 3, that's my quotient. It shows me that I have it twice. So 20 over 3, 20 over 3. That means I have 2 20's in my numerator. I have 2 3's in my denominator, which I can simplify to 20 squared and 3 squared. So 20 over 3 squared became 20 squared and 3 squared. I see something that might have just happened. Let's do it again. 6 over y cubed. So we're going to have 6 over y 3 times, right? So I have 3 6's and I have 3 y's in the bottom, so I can simplify it to 6 cubed and y cubed. So again, just like the property we just saw, we got to distribute our exponent to both pieces. So if I have a fraction with different bases being raised to a power of n, both pieces are going to get the exponent individually. All right? So those are all of our properties. Now let's practice with some of them. This one's to know if this statement is true or false. Is 3 cubed times 3 to the 4th, is that equal to 3 to the 9th over 3 squared? Well, let's simplify each side. This left-hand side is using the product property. So product property, let's see, where is that? That's here, tells me that I get to add my exponents together. So this means I have 3 raised to the 3 plus 4, which I can simplify to just 3 to the 7th. Okay. Our other side, we are dividing and they have the same base. Okay. So that one is our quotient property. They have the same base with different exponents. So I get to subtract these exponents. 9 minus 2 is 7. So do these equal each other? Yes, they do. This is a true statement. Okay. So justifying your answer, that's what I did here. That's justifying it. And then this is my true or false. There's 2 pieces to this problem and you have to show them both to me. All right, next one. It wants to know, are these equal to each other? 5 times 4 squared cubed, is that equal to 5 to the 4th times 5 to the 0 times 4 to the 6th over 5 to the negative 1, all raised to the negative 1. Okay, a lot going on. Okay, we need to deal side by side. So let's deal with the left side first. Okay, I see a product of 2 numbers with different bases being raised to an exponent. This is our product of power of a product property. So that means everything inside is going to get the extra exponent on the outside. So 3 gets applied to both pieces. So 5 gets the power of 3, and 4 squared gets the power of 3. There was already a 4 squared, now it's getting another exponent of 3. This is now a power to a power, which means I'm going to get to multiply my exponents. So 5 cubed stays, but 4 squared cubed, I get to multiply 2 times 3. That becomes 4 to the power of 6. I know I'm done when I have one of each base left over, and only one exponent to each one that is not a negative. So this one is done. All right, let's simplify my other side. Okay, a lot is going on here. I'm going to do these pieces together first. 5 to the 4th times 5 to the 0. Well, zero property tells me that anything to the power of 0 is just a 1, right? So 5 to the 4th times 1, well, that just is going to be 5 to the 4th. Okay. Our fraction over here, the entire fraction is raised to the negative 1 power. This whole thing having a negative exponent means that the entire fraction is in the wrong spot. So I'm going to flip it. So 5 to the negative 1 should really be in my numerator, and 4 to the 6th should be in the denominator. I'm going to go ahead and make this a fraction since we're dealing with fractions now. Okay. So now we have 5 to the 4th times 5 to the negative 1 in my numerator, and I have 4 to the 6th in my denominator. We're almost done, but not yet. I have two bases that are the same, both 5s being multiplied, so I'm going to be able to add my exponents. So that is 5 raised to the 4 plus negative 1, all over 4 to the power of 6. 4 plus negative 1 is 3. So I have 5 cubed in my numerator, and my denominator is still 4 to the 6th. And that's as simple as it gets. Okay, are these the same thing? No, they are not. So this is false. They are not the same thing. Multiplying and dividing are not the same. All right, next we have a matching. So here it wants me to simplify A through F and match it with 1 through 6 on the other side. Okay, so the Roman numerals are already simplified. Let's start with A. I have a fraction raised to an exponent. The fraction is different bases. So this is going to be quotient to a power is the property we're using here. And that means that both pieces of my quotient get the power. So 7 to the 4th over 2 to the 4th. And that is going to be equal to 2. So A gets matched with 2. Part B, I have a product, but they're different bases, and I have an exponent on the outside. So this is going to be product to a power. So everything gets that power. So we have 7 cubed, and then we have 2 squared also being cubed. Well, now I have a power to a power showing up. Power to a power tells me I can multiply. So this is going to simplify to 7 cubed, and then 2 times 3 is 6. So this is going to match with option 1. Part C, I have a product again, and they have the same base. So this is just going to be our product property, meaning I can add my exponents together. 2 plus 2, this gives me 4. So C is going to match with option 4. Part D, I see the 0 exponent. This is going to be our 0 property. Anything to the power of 0 simplifies to the number 1. So 7 squared times 1 is just 7 squared. So D is going to match with Roman numeral 5. All right, E, I see a fraction, I see a negative exponent, so I see negative, right, a negative exponent. I also see a quotient to a power, so I see a fraction with different bases raised to a single exponent. So I'm going to deal with my negative first. So the whole thing being raised to negative means that the entire fraction is in the wrong spot. So I'm going to flip it over. So 2 should be in my numerator, 7 should be in my denominator. I have fixed my fraction, so now I can raise both pieces to the power of 4. So it's going to be 2 to the 4th and 7 to the 4th. So E is going to match with 3. All right, F should match up with 6, but we're just going to make sure. Okay, so I have a quotient again, same bases. So this is just going to be my quotient property since the bases are matching. And that tells me that I get to subtract my exponents. So this is going to be 7 cubed. So that does match up. So F gets matched with Roman numeral 6. Okay. I really like things like this, so expect to see it on future assignments or quizzes. All right, time to beat the test. Crosby and Adam are working together. Part A, Crosby claims that 3 cubed times 3 squared equals 3 to the 5th, but Adam argues that 3 cubed times 3 squared is 3 to the 6th. So which one is correct? Well, what property are we using? Looks like we're multiplying the same base with different exponents. So that is my product property, is what they are arguing over. So we're using the product property. This is me justifying my answer. Okay, what is the product property? Product property told me I can add them together. So which one is adding my exponents together? So we should add our exponents. And right here, 3 plus 2 gives me 3 to the 5th, so Crosby was correct. So Crosby is correct, and this is my justification as to why. One more. We still have Crosby and Adam. Now the problem they're doing is 3 to the 8th over 3 squared. So this is our quotient property that they are arguing about this time. Okay, and quotient property, where is it? Tells me, here it is. Quotient property tells me I am supposed to subtract my exponents when I'm dividing by the same base. So we should subtract our exponents. So we should do 8 minus 2, which is going to give me the exponent of 6. So in this case, looks like Adam is correct, because Adam was the one who subtracted. All right, so I justified my answer and I labeled who was correct. All right, so your notes are done. It is time for your assignment. For your assignment, they bring up area and they bring up volume. So I'm going to remind you what those are. With area, you are going to do length times width. So with rectangles, you just multiply each side together. Squares, remember they are special. All of their sides are the same. They're the exact same thing. So when you do length times width here, you're just going to multiply one side to itself. Okay, so you'll multiply those pieces together. So that's the same thing as your length and width. They're just going to be the same number. It also brings up volume, which is length times width times height. So if they give you all 3 dimensions, you just multiply them all together. When we write our answers, our coefficient is always first, and then our letters go in alphabetical order. So if I had x squared times 5, I don't know, t cubed times z, something like that. Okay, the way I should actually write this is my 5 should come first, and then my variables should go in alphabetical order. So t should come first, then x, and then z. That's just how we write our answers. Okay, so keep that in mind when you work through your assignment. All right, do your best. If you have questions, let me know. And yeah, good luck.